Okay, thank you very much for the nice introduction. My name is Ningbo Wang, and I'm from the Chinese Academy of Sciences in Beijing, China. And today I will give an update on our real-time analysis centers of the IGS. So the title of my talk is the CAS real-time multi-GNS clock and bias estimation, new products streams for the PPP with ambiguity resolution. So as we all know, the IGS real-time pilot project began quite earlier in 2021. The main task of the IGS real-time pilot is, on the one hand, for the monitoring and improve the observation data, as well as the broadcast ephemeris. Another very important task is that to provide precise real-time corrections, including both orbit clock bias as well as the atmosphere corrections. And I guess the official IGS real-time services was launched in 2017, so almost reaching 2 years by now. And the main motivation of our work, starting from the 2024 IGS workshop, there is one recommendation. It says that the major applications of the IGS RTS rely on a 10 centimeter positioning accuracy with fixed ambiguities. And we also recommend the real-time analysis centers to provide, in addition to the satellite clock and code biases, we also encourage or recommend all those real-time analysis centers to provide the additional phase biases to allow on the user side for the ambiguity fixing. So in this table, I give a summary of the status of the real-time products provided by each individual real-time analysis centers. You can see here for all these real-time analysis centers, they're supporting the PPP float application, but only, especially before 2025, only 2 of them can provide the real-time phase bias product. But you can see after the IGS workshop in 2024, now there are 3 additional real-time analysis centers now can provide the real-time phase bias product, including CAS, CHC, and SHOW. So from our side and for CAS, we have provided our new product streams or the CS01 since June last year. So for these new product streams, we support both the GPS Galileo and Beidou 3 constellations. In addition to the satellite orbit clock code biases, we also provide the phase biases for triple frequency carrier phase signals. Additionally, aside from the global VTech maps, we also provided a home-defined message to broadcast also the accuracy information for our provided real-time VTech maps. And our products since June last year was freely accessible from the IGS BKG cluster as well as our regional cluster. So for the computation of for the generation of our CAS01 real-time clock and phase biases, the computation was not so complicated. So we have 2 computation suites. The first one is the full parameter thread. So in this thread, we will generate the fixed ambiguities as well as the station troposphere corrections. And normally for this full parameter thread, it will take about 10 to 15 seconds. And also we have a high rate thread which will calculate the real-time clock as well as the real-time phase bias corrections. Normally for the high rate thread, it only take the time around 1 to 2 seconds. So for the clock corrections, you can see here for the clock corrections, it is the ambiguity fixed clock solution, but we also for the clock solutions, it keeps consistent with the IGS legacy clock models. It means that using the reference code signals following the IGS legacy the clock model. Another point is that because for the code biases, although there is one talk in the morning that for the code biases, in some cases, it shows the time dependent or within day and time dependent variations, but in our case, we now still using our daily code bias product or the CS1 products with the satellite PCO corrections applied. For the real-time phase bias corrections there, one point I should highlight here is that for the GPS L1, for the GPS L5 frequencies here, we applied the interfrequency clock biases or the IFCB parameter estimations by forming the geometry-free and ionospheric-free combinations and estimate the FCB for the GPS L5 signals in real time. And of course, for the real-time phase biases, we provide in the observable specific bias corrections, which can be computed from the linear transformation from the UPD. Then for the data processing, we now at CAS using our own cloud server. For the computation of the real-time clock and the bias product, we now using around 100 IGS real-time stations, and also in mainland China, we use about 20, also around 20 real-time stations in mainland China, and all those stations normally have a mean time latency within 2 seconds. For the input orbit, previously we mainly using the 1 hour ultra rapid products from the GeoBeam company. And since May, we now have made in combination using the combination software from the Geoscience Australia. We now the input orbit in our case is the combined 1 hour ultra rapid product using our 1 hour ultra rapid orbit solutions using the Burning software, as well as the GMB and WHU 1 hour orbit. Here I made a very quick comparison for the clock. We made a comparison with the GFD rapid product covering 1 week. We can see normally for the GPS and Galileo satellite clock corrections, it has the stability better than 0.1 nanoseconds. For some Beidou 3 satellites, the stability is slightly worse than the GPS and Galileo signal. We also made a further analysis to check both the orbit and the clock errors using the signal in range errors. Yes, of course, we also using the GFD rapid products as the reference, but here, in addition to our real-time orbit and clock products, we also using the orbit and clock product from CHC, from the CNES, as well as from the Wuhan University. We can see here for the because this performance analysis was performed during the summer last year. So I would say the quality of the orbit and clock product from CHC and WHU, both products performs the best, followed by our products. But for the CNES products, during that time, the performance was not as good as expected. But I would highlight it here since April of this year, the product from the CNES, their product has back to the normal. We also, on the server side, we also analyzed the ambiguity residual for both the wide line phase biases as well as the edge line, especially when we see the ambiguity residual distribution for the Netherlands, we can see for the GPS and Galileo around 90 percentage of the phase residuals are within 0.15 cycles, but for the Beidou 3, the performance is slightly worse. And here is I give the time series of the real-time phase OSB corrections for the GPS L5 signal biases here. I mean, the IFCB corrections have been applied. Then we also make an analysis for the real-time PPPAR performance analysis here. We're using 100 global IGS stations with the data sampling rate of 30 seconds, and we also using 20 regional of our real-time stations located in mainland China with 1 Hertz data. So for the 30-second data, we can see here for both the yes, here we made a 2-hour reconvergency and the test period covering 2 months in 2025. So I would say when we performed the 20 seconds PPVAR performance for both the real-time products from CARS, from CHC, from WHU, the performance are quite comparable. Normally we can achieve the convergence time around 17 minutes or 18 minutes. When it comes to the real-time 1 Hertz PPPAR, here we set the 10 minutes reconvergence here. We can see for when it comes to the 1 Hertz real-time PPPAR, the performance are quite good from our new CS101 products. Here gives a statistical analysis on the left side. It is the three constellation and the dual frequency real-time PPPAR. It has a mean convergence time around 2 to 3 minutes. But when we using the 3 constellations as well as the triple frequency PPAR, the convergence time was reduced to about 0.8 minutes. And for the IGS SEC, it also routinely performed the real-time PPP performance monitoring, and the monitoring results are routinely available from the IGS real-time working group webpage. So for the summary, I only would like to highlight one point is that since earlier May, because during the April of this year, the Beidou constellation have applied the in-orbit satellite PRN reassignment for our CS01 product. We have adapted to the Beidou 3 satellite PRN reassignment, and our product are available since May 7 of this year. So in addition to the IGS BKG cluster, in case users are interested to our CS01 products, they can also apply an account from our regional cluster. And thank you very much for your attention. Yes, the last point is that because we also have one special issue on this satellite navigation journal, the space issue is on the real-time GNSS services. We together, myself, as well as Axel from BKG and Ria Brock from GFZ, as well as Andre Hochschild from DRR. We 4 people serve as the guest editor of this special issue. Thank you very much for your attention.